NASA just got handed another schedule nightmare with the ISS program, China marches ahead with its aggressive solar system exploration plans, and Astra finds a new lead for its rocket program. As always, we'll have all that and more coming up on this, the 100th episode of This Week in Spaceflight. If you thought the Sonny and Butch story was going to be the end of the ISS schedule nightmares, well, I've got news for you. And yes, I know that's the whole point of this show. I give you the news. So here we go. You might remember a few weeks ago, we talked about how an upcoming Cygnus mission, NG-22, might be impacted due to damage to its container during shipment of the spacecraft pressurized cargo module. That is, the cylindrical section that looks sort of like an oversized beer can. Well, as a result of that, NASA adjusted the cargo manifest for the next resupply mission on board SpaceX's Dragon spacecraft. That would be CRS-32, currently targeting April 21st for launch, in order to add more consumables and food for the space station crew. At the same time, the agency decided to shorten the handover period between Crew 9 and Crew 10 in order to reduce the amount of time the station was inhabited by 11 people instead of the usual 7. Well, now we've got even more information about the situation, and it ain't good. According to a statement from NASA sent out this week, teams found damage not only to its shipping container, but also to the Cygnus pressurized cargo module itself. This means that the agency will not proceed with the NG-22 mission as planned, and will instead jump ahead to the NG-23 mission in the fall of this year. Now, one thing we really don't know is when in this module's transit the damage happened. The pressurized cargo module was built at Thales Alenia Space in Italy, then it was brought to the US for outfitting, and later on, it was integrated with its propulsion module to form the completed Cygnus spacecraft. This means that the module in question did need to travel quite a bit before it was ready to be encapsulated inside of the rocket's launch fairing and poised for launch. NASA says it's now working with Northrop Grumman to assess whether this damaged cargo module can still fly to the ISS on a future flight. Now, this creates a rather interesting situation, albeit one that no one wanted to happen. Due to this jump straight to the NG-23 mission in the fall, the ISS program is now completely reliant on SpaceX and Russia for crew and cargo transportation to and from the station. But even when Cygnus was in the mix, its launch was going to be on a Falcon 9 rocket. Northrop Grumman's Antares 230 rocket was retired a few years ago because of the Russian invasion of Ukraine, since the rocket's first stage engines were Russian and the tanks were Ukrainian. Thus, the company teamed up with Firefly Aerospace to create the Antares 330, which will utilize a Firefly-made first stage and a solid-fueled upper stage from Northrop. However, that rocket won't debut until at least next year, so for the time being, Cygnus was launching on Falcon 9, as it did so on the NG-20 and NG-21 missions. NG-22 was supposed to be the last Cygnus launch on Falcon 9, as NG-23 was scheduled to be the first on the Antares 330. But with the schedule change, this might change as well. NG-23 was also going to debut a new and stretched variant of Cygnus, capable of carrying 30% more cargo to the ISS. This is because it'll be made up of 4 barrel sections instead of 3, as it currently is. This also makes things more complicated because if NG-23 also flies on Falcon 9, the ground operations will be different. In order to accommodate late cargo load capabilities on Cygnus while mated to Falcon 9, SpaceX designed and built a fairing with a special door to access Cygnus while horizontal on the pad. A longer Cygnus would likely mean a different door placement, design, and maybe even new procedures to execute this. And all of this just for one cargo mission that's been delayed. Isn't spaceflight fun? Now, none of this would be an issue if NASA had, let's say, Dream Chaser online and up and running. This spaceplane has suffered several delays of its first launch to the station, and multiple tests still remain on its path to a first flight. If it was ready, things certainly would have been easier on NASA and its international partners to plan all of this. Now, it's not the first time the ISS program finds itself in this kind of a tight situation, though. About 10 years ago, there were several different cargo flights from Cygnus, Progress, and Dragon spacecraft that failed to reach the station in a roughly 1-year span. This resulted in dwindling resources on the orbiting outpost, as well as the loss of hundreds of millions of dollars in hardware, research, food, and supplies. So when compared to that, this is actually a walk in the park. It's always important to remember that these kinds of things do happen, and it really showcases the versatility of the program, that they can continue to work despite the many wrenches that are thrown at it. Sure, maybe mainstream media won't talk about stranded astronauts and dwindling resources on the ISS now, but you can always trust us to cover it as it happens, just like we always do. And if you want to keep informed on all things space, you know the drill. Like and subscribe and ring that notification bell so you don't miss any of our videos and live streams. We also got some interesting discoveries from Mars's army of robots this week. Curiosity found traces of fat, but let's start with Perseverance, which found a very strange rock. The rover has been looking at rocks pretty much since it arrived on the red planet in 2021, but this one stood out as it's made up of hundreds of tiny spherical objects. Percy spotted this rock while sampling another rock nearby. This isn't the first time spheres like these were found on Mars, as both Opportunity and Curiosity spotted spherical rocks as well. These features may have been formed by various geological processes, and scientists are currently trying to figure out how this particular rock formed, as well as how it got to the place where Percy encountered it. Meanwhile, Curiosity detected the largest organic molecules ever found on the red planet. Scientists detected the molecules in a sample Curiosity collected in 2013. The sample was heated twice in an oven in the rover's Sample Analysis at Mars, or SAM, instrument suite. The scientists were originally looking for amino acids, which they didn't find in the sample, but they did notice that it released some other organic molecules. Working backwards, they found that these molecules were the remnants of fatty acids that were preserved in the sample. Fatty acids are an important building block for life on Earth and make up cell membranes, among other things. However, these fatty acids are not exclusively produced by life, and they can also be made by geological processes. What's interesting, though, is that some of the fatty acids found by Curiosity contain longer chains of carbon atoms than are typically found in fatty acids made by non-biological processes. Regardless of the origin of these molecules, this is a tantalizing find in the search for signs that life may have ever existed on Mars. Some of the most exciting space missions are the ones that visit other planets. Exploring worlds beyond our own helps us understand the history of the solar system and how we came to be. But one of the most pressing questions scientists want to answer is whether there's life out there, or at least whether there was life at some point. Well, this week we got a glimpse into China's plans for planetary exploration as the country's Deep Space Exploration Laboratory released an image detailing its plans on the social media platform Weibo. The roadmap contains some very ambitious missions, with a focus on the search for extraterrestrial life. The first mission on the roadmap is the Tianwen-3 Mars Sample Return mission. China has been planning this mission for a while now, and we've discussed it in previous episodes of This Week in Spaceflight. The goal for this mission is to collect some Martian soil and fly it back to Earth for analysis by scientists. The mission planners hope that the sample contains traces of ancient life. The mission is currently scheduled to launch during the 2028 Mars transfer window. Earlier this month, China released a call for international proposals for payloads to hitch a ride to the red planet on this mission. According to this document, Tianwen-3 might return Mars samples to Earth as soon as 2030, though previous versions of the plan estimated 2031. The next mission in the plans is, perhaps not surprisingly, the Tianwen-4 mission, set to launch in 2029 on a trip to Jupiter. This mission will also study the Jovian moon Callisto by releasing a probe to impact the moon. Previous iterations of this plan included an additional probe that would make its way to Uranus, but that one isn't shown on the image released this week. Venus can also expect a visitor, which is currently set to launch in 2033. Previously, China considered launching an orbiter called the Venus Volcano Imaging and Climate Explorer, or VOICE, but last year these plans were changed to include an atmospheric sample return. With these samples, China hopes to discover if the Venusian atmosphere could potentially be home to microbial life. In 2038, we can expect the launch of a Martian research station to study if local resources can be used to support missions to the red planet. This is known as in situ resource utilization. Initially, this research station is expected to be robotic, but it might see human visitors in the future. Finally, the plans call for a mission to Neptune and its largest moon, Triton. This one might be launched around 2039, but another proposal posted on Weibo suggests that the launch may happen as soon as 2033. Either way, we'll have to wait a long time before it arrives, as the trip to Neptune might take as long as 15 years. Once there, it'll search for life in the oceans below Triton's icy crust. These plans are all very ambitious, but China's recent efforts to explore the solar system beyond Earth have been very successful. The Tianwen-1 lander and its rover Zhurong proved the country's ability to conduct interplanetary missions. Meanwhile, China's recent missions to our own moon have matched that success, with last year's Chang'e 6 mission returning the very first samples from the far side of the moon. NASA used to lead the way in deep space exploration, and it still does, but it might hand the baton to China soon. The agency is planning some ambitious missions of its own, but if successful, China will take the lead, even if NASA manages to stay with its most aggressive timelines. NASA is planning its own Mars sample return mission, but as we discussed in previous episodes, those samples won't make it into the hands of scientists before 2035, years behind the 2030 or 2031 that China is planning for. Though a mission to Uranus or possibly Neptune headlined the most recent Planetary Science Decadal Survey, no such mission has actually been proposed as of today. The unfortunate reality is that NASA's budget for planetary science has only been decreasing in the last few years, not to mention the rumors that the new administration may want to cut NASA's science budget by as much as 50%. Without a budget, the agency won't be able to dream up big plans to explore. This is all in stark contrast to the plans announced by China this week. Of course, a lot can happen between now and when these missions are supposed to launch, but at least there are missions to look forward to. While we'd love to see NASA announce ambitious plans like these, we're glad to see China pick up the slack. Now we'll take a look at some other stories across space, starting with the European Space Agency, which said farewell to its venerable Gaia space telescope this week. The spacecraft was launched in late 2013 on a 5.5-year mission, but lasted until this year, much longer than planned. Throughout its mission, Gaia observed stars and galaxies throughout the universe and tracked hundreds of thousands of asteroids and comets in the solar system. Its observations revealed many surprises about the Milky Way and gave astronomers a better picture of our galaxy than ever before. And there's even more to come, as scientists are still processing Gaia's data and plan to release more next year. The spacecraft has now run out of fuel, forcing ESA to end the mission after Gaia observed its final star back in January. It spent its mission at the Sun-Earth Lagrange Point 2, a stable point where many spacecraft hang out, including the James Webb Space Telescope and Euclid. But that's not a great place for an old and uncontrollable spacecraft, so Gaia spent its last remaining propellant to move into a retirement orbit around the Sun. After that, spacecraft operators pacified the spacecraft and intentionally corrupted its software to ensure that it would never turn back on. Then ESA finally powered down Gaia on March 27th. At this bittersweet moment, we'd like to congratulate everyone who worked on Gaia for its tremendously successful mission. NASA has achieved a crucial milestone for its Artemis II mission. On March 23rd, the agency completed the stacking of the Space Launch System's core stage inside of the Vehicle Assembly Building in Florida. The core stage was processed at High Bay 3 inside of the building over the last few months. The stage was later moved to the transfer aisle before being lifted and installed in between the two solid rocket boosters, completing the first stage of the rocket. Up next in the rocket stacking should be the installation of the launch vehicle stage adapter over the core stage, followed by the interim cryogenic propulsion stage to finish off the rocket stacking. Artemis II will be the first crewed flight of Orion and SLS, which means once SLS is complete, NASA will integrate Orion on top. But for that, there may be still a few more months to go. Believe it or not, Astra is still alive, and it just got quite the addition to its team. This past week, the company announced Dr. Alan Weston has joined Astra as the head of launch program. Dr. Weston previously worked on hybrid electric airships at LTA Research. He was the director of the Lightweight Exo-Atmospheric Projectile Program during the 1980s, and also worked as chief scientist for the U.S. Air Force Space and Missile Systems Center. He also worked at NASA's Ames Research Center, where Astra CEO Chris Kemp also worked less than 20 years ago. In his position at Astra, Dr. Weston will be overseeing the development and deployment of Rocket 4, Astra's next rocket. According to Chris Kemp on social media, the company is targeting a first test launch of this rocket early next year, followed shortly after by customer launches. NASA's Starling has collaborated with SpaceX's Starlink. Well, that's a little confusing, but the mission is actually pretty cool, so let's dive in. NASA's Starling mission uses 4 CubeSats that were launched by Rocket Lab in 2023 with the main objective of demonstrating autonomous planning and execution of orbital maneuvers. The agency wants to use this technology on future science missions that use swarms of satellites. Starling completed its mission last year, but the satellites had plenty of life left in them, and that's where SpaceX comes in. Much like NASA's mission, SpaceX's internet satellites are also capable of maneuvering autonomously, and NASA wanted to test if the systems could, perhaps, work together to avoid collisions. In the past, this would have required phone calls or emails between satellite operators, which meant that avoiding a collision could take days. That is, of course, way too long, so SpaceX worked with NASA to build a system that can detect potential collisions collisions and coordinate the traffic to avoid disaster. Normally, SpaceX moves out of the way from any other satellite that gets too close, but this time, NASA's Starling satellites yielded to SpaceX. Together, Starling and Starlink demonstrated that large satellite constellations can operate together safely, which is great news, as the rapidly increasing number of satellites will require tight traffic control to avoid littering space with debris from collisions. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. Let's start off with NASA's Parker Solar Probe and the scorching heat of the sun. On March 22nd at 22:42 UTC, NASA's Parker Solar Probe made its 23rd closest approach to the sun of its entire mission, matching its own record for shortest distance to the sun and speed around our own star. The spacecraft arrived at its current orbit following a Venus flyby executed in November, after which it had its closest approach ever on December 24th of last year. Just like that encounter, this one is the closest yet, and it was also successful. NASA confirmed that the probe phoned back home on Tuesday, March 25th, confirming good health. Through these approaches, Parker will be able to gather unprecedented data on the solar corona and solar wind. Moving back down to Earth, we had a few launches this week, starting with the Falcon 9. Liftoff took place on March 24th at 17:48 UTC from Space Launch Complex 40 at Cape Canaveral in Florida. The rocket was carrying out the NROL-69 mission for the National Reconnaissance Office. While the mission was classified, things like hazard notices and the performance needed from Falcon 9 give us a clue as to what kind of payload it might be carrying. It appears that for this mission, the NROL-69 payload was a Naval Ocean Surveillance System satellite, which is a type of signals intelligence satellite operated by the U.S. Navy. These satellites often orbit the Earth in orbits ranging between 1,000 and 1,200 kilometers in altitude and at an approximately 63-degree inclination. Given that orbital inclination, these payloads have traditionally been launched from Vandenberg, and in fact, SpaceX launched one of them from here in 2022 on the NROL-85 mission. However, with Falcon 9's payload performance, it's still possible to launch into these types of orbits from the Cape if the rocket performs an inclination change later in the mission. In fact, due to this peculiar mission profile, many people in Northern Europe were able to observe the dump of propellant from the Falcon 9 second stage after it performed its C-orbit burn following payload deployment. This is a totally common procedure that the Falcon 9 second stage performs after its mission is completed in order to go into a safe state by venting excess propellant, lowering its tank pressure, and powering down its batteries. On other missions, this maneuver often ends up taking place over Australia or over the middle of the Atlantic Ocean, so it's not something that Europeans would be very used to seeing. If you saw it and had no idea what it was, well, now you know. The first stage for this mission, B-1092, was a rookie one, flying for only its second time on this mission. It successfully returned to Earth, landing back at SpaceX's Landing Zone 1 ground pad just a few miles south of the launch site. From the southern hemisphere, we also had another Electron launch this week, the 5th overall for this year. The mission, called Finding Hot Wildfires Near You, started off on March 26th at 15:30 UTC from Rocket Lab's own spaceport in New Zealand. Electron was carrying 8 satellites for Aurora Tech into sun-synchronous orbit. These 8 satellites are part of a constellation of spacecraft that Aurora Tech is building in orbit to better monitor wildfires with more frequency to assist with better response times here on the ground. Hence the cheeky name for this mission. The satellites employ a set of thermal infrared cameras to spot the wildfires and changes in the landscape to monitor their growth. And with multiple of these satellites going into orbit, the company hopes to have a nearly continuous observation capability. That same day, just a few minutes later, we had a Changzheng 3BE rocket launching from China. Liftoff took place on March 26th at 15:55 UTC from Launch Complex 2 at the Xichang Satellite Launch Center. The mission was carrying the 4th Tianlian-2 satellite into a geosynchronous transfer orbit. Tianlian-2 satellites are Chinese communication relay satellites used to support communications between satellites orbiting Earth and ground stations when they're outside of ground station coverage. These satellites are akin to the U.S. Tracking Data and Relay Satellite System, or TDRS, which NASA uses for communication with several of its orbital assets, like the International Space Station. China uses the Tianlian satellites in the same manner, such as in support of its Tiangong Space Station for operations outside of ground station coverage. And to wrap up the week, we had the launch of a Starlink mission from Vandenberg. Liftoff of Falcon 9 occurred on March 26th at 22:11 UTC, carrying a batch of 27 Starlink V2 mini-satellites into low Earth orbit. The first stage for this launch, B-1063, was flying for a 24th time, and despite its age, it successfully landed on SpaceX's drone ship, Of Course I Still Love You. With that batch of satellites, SpaceX has now launched a total of 8,144 Starlink satellites, of which 1,009 have re-entered, and 6,492 have moved into their operational orbit. Going into next week, on March 29th, we'll have a partial solar eclipse as seen here from Earth. The eclipse should be visible in the northern hemisphere, primarily over northern Europe and western Russia. The northeast of the United States, as well as Canada and Greenland, will also be able to see the event. This is only a partial solar eclipse, which means we won't have a path of totality, but there is a path of maximum eclipse, which will start from the central Atlantic Ocean and should move north across the Earth, passing by Canada, grazing the North Pole, and finishing in Russia. If you're in the path and you want to observe it, remember to never look at it directly and use appropriate gear, or else you might risk damaging your eyes while trying. It's not every day that we can say a rocket launch might happen during a solar eclipse, but this weekend, there might be a possibility. Next week, ESAR Aerospace will try to get its Spectrum rocket off the ground for the very first time. After several delays due to weather, the company may try to launch as soon as March 29th, with the 3-hour launch window opening at 11:30 UTC. If that date and time holds, that'll be right as the eclipse is happening over Norway. And if you don't want to miss this launch, you're in luck, because NSF is providing launch livestream production services to ESAR, so we'll be covering it as it happens. Our team is on site and ready to support from the land of the midnight sun. This weekend, we'll also have the launch of a Changzheng 7A rocket from the Wenchang Space Launch Site in China. The launch is currently targeted to take place within a 78-minute window that opens on March 29th at 15:57 UTC. Firefly's Alpha rocket is also waiting on good weather to take off to the skies, but the latest notices indicate the company may be aiming for another try this weekend. The 68-minute launch window for this mission, dubbed Message in a Booster, is set to open on March 30th at 13:37 UTC. Schedules are still fluid since the company hasn't committed to this launch date yet, so don't be surprised if there are further delays. NSF will also be providing livestream production services to Firefly for this launch, so we'll be covering it on our channel as well. Next week, we'll also have a trio of Falcon 9 missions to end the month of March and kick off the month of April. First, we'll have a Starlink launch from Florida, with the 4-hour launch window opening on March 30th at 19:16 UTC. After that, we'll have another Starlink launch, this time from Vandenberg, with the 4-hour launch window opening on April 1st at 1 minute past midnight UTC. Then, just a few minutes later, SpaceX will also be launching the From-2 mission, the first crewed flight to fly in a polar orbit around the globe. For this mission, Falcon 9 will be launching southeast from Launch Complex 39A, performing a dogleg around the southeast coast of Florida as it inserts Crew Dragon into a 90-degree orbital inclination. The window for this mission, set to take place on April 1st, is approximately 5 hours long. Within that window, there are 4 available launch opportunities. The first is 1:47 UTC, the second at 3:20, and the third and fourth at 4:53 and 6:26 UTC respectively. And to wrap up the week, we'll have another launch from China, this time with a Changzheng 2D rocket. The 37-minute window for that launch opens on April 1st at 3:52 UTC. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.